At this point, ANSYS knows what is the boundary value problem we want it to solve. So let's get it to solve it and obtain the displacements at the nodes. If I go back to this slide from pre-analysis, okay, so the boundary value problem has now been input into ANSYS. And ANSYS also has the element by element polynomial interpolation for U and V because we provided with a mesh, and we saw that it's going to use a quadratic interpolation or a second order interpolation over each element. So it has all the information it needs to discretize the boundary value problem and obtain the set of algebraic equations in nodal displacements, i.e. it has information to calculate K, the stiffness matrix K, and the force vector F. So it'll do that, and it'll invert it to get the nodal displacements. This is a step in which there's a lot happening under the hood, but as the user, you just have to hit solve. So let's do that. I love it because ANSYS is taking care of a lot of the details, which means we can focus on the problem solving, solving interesting engineering problems. Okay, so I can, I usually like to highlight solution and then say solve. Okay, that's it. And it's done that. So now if I highlight mesh, it has U and V displacements at all of the 2936 nodes. So I can, so that's all there is to obtaining the numerical solution, and we can move to post-processing. By the way, if your model gets ASCII or something, you can click on Z and you can zoom in and out using the middle mouse wheel, and you can also say zoom to fit. And let's also save the project. File, save project.